Hi, this instructional video is about logarithms and finding its inverses. Last time we took an inverse of a log function, but this time, how about natural logs? And so, here we have number 1. And continuing with the definition of a logarithm and the concept of inverse function, where x and y switches places, here we have y is equal to natural log of x minus 1. And so I'm going to go ahead and switch y and x, so we get x is equal to natural log of, well, y minus 1. Now, when we talk about natural logs, isn't that kind of like saying, what is the log base e of y minus 1? And if I write that in exponential form, isn't that like saying e to the what power gives you y minus 1? Well, that e to the what power has to be the unknown x. And since x is over here, we're going to use this equation to replace the entire thing. Substitution, huh? So we end up with, rather than an x, we're going to raise it up instead and become e to the x power equals, we no longer need the notation natural log because now it's represented by y minus 1. And then solve for y to make into a function form by adding 1 to both sides of the equation. And using the identity, if I move it around, we get y is equal to e to the x plus the 1. Simple in its procedure, but conceptually, it's quite complex. But anyway, that is my inverse function of this natural log. So following that, you try this one. Okay, so you said step 1, to find the inverse, switch the domain and the range, the x and the y that is, switch them and rewrite it. So we get x is equal to natural log of y plus 2. Now, using this idea of writing into an exponential form, if you think about it, you could see it right away that this x now can be raised into an exponential form to make it into e to the x equals, now we no longer need the natural log notation, so instead we say y plus 2 now. And to make it into a function form, we're going to subtract the 2 to both sides of the equation. And if I write it in some sort of a standard form, we get y is equal to e to the x minus 2. And this function is now inverse to the original natural log function. And finally, how about that one? It's a little tricky. Okay, so you said, well, still, I'm going to stick by the procedure and switch the domain and the range, x and the y. So I'm going to write it as x is equal to natural log of 6y. And then if I write that into an exponential form, it's going to become e to the x is equal to 6y. Not so tricky after all, huh? And to solve for y this time, we're going to divide the coefficient 6 to both sides of the equation. And writing in some standard form, we go y is equal to e to the x over 6. We'll talk about graphing these inverse functions later on. I'll see you in class.